Hello and welcome to another episode of Writer and Geek Show. We are your hosts Vishnu and Shankar. And in this episode, we're going to talk about... What are we going to talk about?
Actually, even I don't have any idea. I have just jotted down some random stuff here and I think we'll pick up as we go.
So basically what we do every week, right?
Exactly.
Well, I think this will do. It's like,
We can expand this into one episode.
Yeah,
That's not a problem. And
cool.
Did you realize that this is our 100th episode?
Oh, yeah. Okay. Yeah, we did talk about this like a few weeks back, right? But I kind of forgot about it. Anyway, 100 is just a number.
Yeah, good that you phrased it that way because I had some notes about numbers and stuff like that. Like, how much do you know about numbers?
I think I know from 0 to
Did you like
infinity or something.
Good. Did you like maths in your school? Was it your favorite subject?
I think from till like 10th grade or something, I used to like maths. But after that, when the whole integration thing fell on us, right? That's when I started losing it. But till then, I used to be a good math student.
Well, no offense to any of my maths teachers. I used to hate the subject actually.
Okay. Yeah, my thing was different because I remember I used to fail in all the subjects, right? But when I used to fail in all the subjects, the only subject I used to pass was maths.
And if you look at my maths history, right? Maths history in the sense my marks in maths, it was always like a sinusoidal wave. So I will do great in one exam and then I'll do really bad in the next and then do great. So I still remember during my 10th standard board exams, before board exams, we have this number of model exams, right? Just preparing yourself for the real thing kind of a thing. So in the model exams, I used to do well in one. I used to get around 80% mark in some one exam, and next exam I'll get around 40 to 50%. Then I'll get 80. Then it will go down. And I still remember just before the actual board exam, I got really good marks, like some 84 marks or something. And I still remember my teacher came and said, "You know what? I'm really worried about you because you scored really good in this exam. So that means your board exams are going to be really bad."
So basically, they knew that you're going to fuck up.
But I didn't.
Yeah, you didn't.
Well,
even I didn't actually,
I did 2 years after that, to be honest. In 12th standard, I had a major setback, which is a story for another day or maybe an unscripted episode or whatever it is.
I was clever.
I was looking forward to engineering and stuff. Anyway, so that is a little bit of our history with mathematics. What I wanted to talk about today is about how did these numeral systems come into existence? Who invented them?
And we Indians.
You just broke the suspense. Anyway, so those are the things that I wanted to touch upon, and also a little bit of revision about what numbers are, right? Like, do you remember what is the difference between integer and real numbers and all that kind of stuff?
Before we get into that, I feel that I'm not going to like this episode at all because revision? Are you serious?
It was a revision for me because when I was researching for this, right, I came across this, this concept of whole numbers and fractions and real numbers and then integers and all that kind of stuff. I genuinely realized that at that point that I don't really know what these things actually meant because there are these real numbers, imaginary numbers, and then you have whole numbers, and then you have natural numbers. Like, what are these things?
Does odd and prime numbers come under any of these things?
Yeah, of course. Odd and prime numbers are a part of real numbers.
So I know something, thank God. This is like how, like, you're learning maths right now. This is the same as a writer, me being a writer, learning grammar. I still don't know the definition of nouns.
Tell me one thing.
Verb. I don't know any of those things.
That's okay.
Yeah.
As long as you have that basic understanding of how to use a sentence. Do you know whether 0 is is an odd or even number?
It's nothing, right? It's on its own, right?
I think 0 is an even number.
It's an even number. Yeah. Okay.
Anyway, I might be wrong. But then let's just touch upon, because I'm not an expert in mathematics and I did really poorly in maths. So yeah. Anyway, I'm not gonna delve deep into this because maths has never been my strength, and my teachers can attest to that. So I'll just run through a few facts which I randomly collected over internet and assume that we are India's best podcasters.
So disclaimer in advance, this is a revision. I have never been a revision guy. I never used to revise in school. I used to be the remedial class kind of guy who used to fail, and then the teachers will call and make us go through stuff. So this is gonna be my first revision. I'm looking forward to it.
So let's go back many years into the prehistoric times, right? Somewhere human beings felt a need to start counting stuff.
I thought need for speed. Okay.
Well, that was a really bad joke. But then I think this would have started. Let's take a case, a scenario. Maybe man started domesticating animals.
Okay.
Like sheep or whatever it is. So the sheeps might go out for grazing. I'm just making up the scenario. Okay, this is something that would have happened or may not have happened. So in the evening when they come back, how does he know that how many sheep have gone out and how many have come back?
He counts the sheep.
Exactly. So the easiest way to start counting is using the fingers because that is a readily available stuff, right? So probably he would have started counting with his fingers and he would have memorized, maybe if he has 9 sheep, he would have counted 9 in his fingers and he knows that, how many sheep.
He's got a handful of sheep.
Exactly. Now sheeps, I believe that they would have multiplied in number soon, right? And it became difficult for him to count on his 10 fingers because the numbers have gone beyond 10. So what do you do? I think that is when they invented these tally marks or some similar kind of stuff. Tally marks are the ones which we would have used while playing cards and stuff, right? You mark 4 dashes for 4 and then when the 5 to mark the number 5 you just cross it.
There is another way where you mark it as 5 and then you cross. The cross doesn't have a value. There are 2 kinds. Yeah. It's a little confusing because I have learned there are like 2 ways to tally.
You can actually keep drawing dashes and make it 10, 50, but I think the whole purpose of having that cross is to group them, so that visually it's easy for you to identify. So if you see a group of 5, right, 2 groups of 5 makes 10. So I think it helps in the counting process. So I think that is where it would have started. So even the tally marks look similar to fingers, right?
Yeah.
This is my theory actually.
And if you want to know more about tallying, probably you should watch a prison movie. All the prisoners, they'd be sitting and, tallying how many days they've spent on the walls.
Is it there in Castaway also? How does he keep a track? No, he draws dashes on a cross or something.
I think he follows something different. He's like a much more advanced guy, right?
I wonder how Robinson Crusoe was doing it. We should go and read that novel again. Anyway, so that's probably how the counting system started, right? So easiest thing was to start using fingers. And if you look at it, Roman numerals, right? It is actually an extension of this tally system. You look at how they write 1, 2, 3, 4, everything is single lines. When it becomes 5, they use a completely different symbol, which was one of the Latin alphabets. In fact, everything is alphabet. It's like I, V, then you have X for 10, right?
C for
100, I think, or 50. M is 1000,
yeah, 1000.
Right? So there is D, C is 100 and D is 500 is what I think. So they started extending this tally system in that way, and to make things much more easier than to have like multiple groups of tallied numbers, what they did was they found out they put it in such a way where if you put a smaller number next to a larger number, that means you'd subtract the smaller number from the larger number. If the smaller one is on the other side, on the right side, that means you add both numbers. So if you put a V and a I, that means it is 5 plus 1 is equal to 6. If you put it the other way, which is how usually 4 is written, to avoid writing 4 I's, you put an I before the V, so that means you subtract I from V, which is how the entire numeral system. But again, it is cumbersome, right? You don't have a representation for 0. And if you are writing really big numbers, that thing can become like a long word as well.
I think I've read somewhere like some philosopher, instead of using the numerical system which we use presently, he went with Roman numerals, and he had to write down till like some 40,000 or something, and it just went out of hand, it seemed. I don't remember exactly what it was. Probably I should have done some research.
Anyway, so this was a completely different system from what we have right now. Our numerical system today is something that is based on place values, right? You would have learned, this is again a revision from our school times. So place value in the sense, each integer, depending on where the position of that integer, that particular digit is in the number, it has a particular place value. Ours is base 10.
Yeah.
So the first place from the right will have a base value of 10 to the power 1. So let's take a number like 295. 295 is equal to 5 into 10 to the power 0. Anything to the power 0 is 1.
Yeah.
Right? So that is 5 plus 9 into 10 to the power of 1.
1.
So that is 90.
9.
So 5 plus 90, that becomes 95. And you have 2, which is on the 100th place, which is 10 to the power 2. So it is 2 into 10 to the power 2. 200. That becomes 200. So 200 plus 90 plus 95 is 295. That is the basis of our current numerical system, which was not existing in Roman system, which made it really difficult to do calculations and stuff like that. Imagine doing multiplication in Roman numerals.
You just can't. You can, but it's difficult.
It's more of I feel it would be more of effort. I'm not going to do that exercise here right now. So that is why there was a need for a new system, right? So somewhere between 1st and 4th century, someone in our beautiful country of India, I mean India was not India that time, but in this region which has become present day India, devised a methodology which became the basis of modern number system. This system later came to be known as the Hindu-Arabic system or Indian or Arabic numeral system based on whom you're talking to. And how it came to be known like that is something that I'll explain in a bit. But this became the basis for the modern system, where you have this place value system and numerical calculations became really easy. And also 0, there was a digit for 0 as well, which signifies nothingness, right? Which is completely absent in Roman numerical system as well. And we have heard about Aryabhatta, who was a very famous scientist, astrologer, astronomer, etc., mathematician from India. He was like an all-in-one kind of a guy. He lived around the 4th century and 4th, 5th century, and it's said that he has he was largely involved in number systems, algebra and all that kind of stuff. There is also a speculation that he invented 0, but that is not something that we can prove or anything.
We don't have any evidence for that.
I think he's the one who gathered a lot of theories and theorems and everything together. He's mostly known for the approximation of pi, the number system pi, right? So, do you know what does pi signify?
Pi is 22 by 7 or 3.1.
Yeah, why is it 22 by 7? What do you mean by 22 by 7?
I have no idea.
Right. So let me put it this way. If you have a circle, let's take a circle, right? So pi simply is the circumference divided by the diameter of the circle. So there is a ratio. So you know that if you draw a straight line and you connect 2 points with with the center as a line center, and if you draw a circle around it, the diameter times pi is equal to the circumference.
Yes. Yeah.
And
that I know.
And why is pi such a significant number? One of the characteristics of pi is that it's the fraction that you get out of pi by dividing the circumference by diameter never repeats and it never ends.
Yeah.
That is why there are so many people who try to remember these many digits of pi and all that. Now, Aryabhatta, so that means there is a significant amount of uncertainty with that number. So Aryabhatta came up with an approximation which is considered to be one of the most closest approximations ever of 3.1416. What we need to note, why is that so significant, is because the realization that pi is an irrational number happened in the Western society only around 1761.
1761.
That's around just 1300 years later.
Okay, just before America came into existence as we know it.
Yeah, the independent America. So that is why it is significant. Now, what happened during the medieval times? Now, Islam was, Islam came up during this time, around 6th century. There were a lot of Islamic scholars and scientists at that time. Okay, there were people who were really interested in astronomy, astrology, science and mathematics and all that. And there was someone called Muhammad ibn Musa al-Khwazimi.
Okay.
So he was born in present-day Kazakhstan, and he was one of the lead astronomers in House of Wisdom in Baghdad, which was a big, center for science and studies and all that kind of stuff.
House of Wisdom.
House of Wisdom.
That sounds like, majestic, epic kind of stuff. Right. Then the Britishers have House of Commons.
You know what this brings into mind? House of Wisdom brings, it feels like something in that Aladdin kind of a thing, right? I mean, that Arabian world and all that. So he was one of the astronomers there. And he did a lot of work in understanding the number system, and he also referred to the work of Aryabhatta and all, and some other works which had happened even in China. And he also studied the work of Ptolemy, and he proved most of his work was kind of invalid, right?
I wanted to say BS.
Well, yeah. Out of respect, kind of understood that much of his work was not valid enough. But he is the one who put everything together. He wrote a few books and stuff, and he introduced the Western and Arabic world to the stuff that which came out of India, mostly some of Aryabhatta's work and other numerical systems and all that. This is the reason that it's called Hindu-Arabic system.
I think at one point it was called the Arabic system, right?
I mean, see, that's why I said it depends on whom you ask.
Yeah.
If you go to the West, who introduced them to the system? It was from the Arabia, right? So that it makes sense for them to say it is Arabian system because they are the ones who told me, right? But if you look at all this history and what went behind that, it makes sense to call it Hindu-Arabic system. I'm not gonna argue about it because, I mean, mostly the person who spreads some concept around the world gets the credit, and it's fine, right? I mean, who is going to
same way? Some people are getting the credit for spreading corona. Too much, huh? Well, India, like Patliputra used to be the main center, right, back then?
Aryabhatta was from Patliputra, and they had big university there, one there and one in Takshashila, which was
Takshashila.
I think which is in current present day Pakistan, I think. Takshashila was somewhere in the north in Jammu.
Oh, I didn't know that. I thought it's
I don't know
India.
exactly where it is, but it was in India at that time. But I think if you look at the exact location, probably it might be somewhere.
It was not in India at that time. There was no India. Anyway, there is a theory like conspiracy. Can we call it a conspiracy? I don't know. Like Aryabhatta is from Kerala, right?
Someone said Kasaragod as well.
Yeah, I know.
Someone told me that Aryabhatta is from Kasaragod, and I was like, that's not what I heard, because when we were studying, I always heard that he was from Patliputra.
Maybe he's your senior or something. He was from LBS.
Studied in LBS college, really? Alumni meet, I'll go.
Yeah.
But I've heard that as well. He's from Kerala. He's from southern Karnataka, and he's from Kasaragod and all those things. I don't know, because I'm not really sure about it, but all the records say that he was from Patliputra. So that is somewhere in present day Bihar, Patna. Right, that's where it is. And he was also very popular in predicting the eclipse of moon and stuff like that. So he was not just a mathematician, he was an astronomer as well.
I make the same mistake a lot of times.
Astrologer, right? Yeah. He would have probably been an astrologer as well. We don't know. But so thanks to Al-Khwarizmi, a lot of this work got translated and spread into the Western world as well. What is his Latin name?
I think that'll be better than what his
algorithm is. Now that is a basis for the word algorithm, right?
Oh, wow.
That's what it is. And 300 years later, Fibonacci was really fascinated by his work, and he is the one who literally brought this number system into Europe.
Oh, right? And he created the Fibonacci sequence.
Is that related to this? I don't know. But that Fibonacci series is entirely in the numerical system that we use currently, right? So everybody knows what is Fibonacci, but just a revision as well.
I don't think everybody knows.
So Fibonacci series is a series where it's like a series of numbers where one number is the sum of the previous two numbers.
Yeah.
So I think it starts with 0, 1. Then 0 plus 1, which is 1 again. Then the next digit is 1 plus 1, which is 2. Then it becomes 3 because 2 plus 1. Then it becomes 5, 8, 13.
I think just go read Da Vinci Code and
the entire novel is based on Fibonacci series and all that. I think John Langdon is very...
Leave the controversy side and just go read it, man, for the sake of it.
What is the controversy around it? Oh,
what is the controversy based on Da Vinci Code? How can
I think you should look at it more like a literature.
Yeah.
The thing is, it's easy to say that, but here even releasing a movie on some fiction becomes a big deal, at least in India, right?
See, we should all look at how the Scandinavian people are. Norse gods. They're all comic characters now, right?
Like Loki and Thor.
We have this amazing characters because superheroes because of these guys.
So if they were like how we are, they would have protested against releasing any Marvel movie.
Yeah, imagine not having the Marvel series. I'm pretty sure a lot of people would be happy, but I like the Marvel.
I will not be happy. I really love them. Again, in 13, after 300 years, that would be around medieval time is when this was introduced into Europe. And, those days in Europe, mostly Roman numerals were used because, it was considered to be from Rome, right? So even though the system came into Europe around the Middle Ages, right? There was some region, and they were using Roman numerals before that. And there were some areas where this system was not accepted or banned.
Okay.
Florence is an example because they said that this system is so easy to manipulate. So in public records, the digits, the way it is written, it can be considered as, interchangeable or whatever it is. Might have had genuine reasons as well. But then around 15th century, the entire system was moved over to numerical system because of the shortcomings of Roman system. We still use Roman systems here and there, but you very rarely see them. I think mostly you see in bullet point. If you're not using bullet points, you sometimes use numerical.
Yeah, it's just a way for me to stylize. That's all I use it for because it looks good sometimes when you use
in books. In books also they look really good.
Yeah. So that's all. Other than that, I don't know.
Yeah. So now the number system that we use, a little bit about that, is base 10, right? So as I explained earlier, the place value system, right? So the rightmost digit is 10 to the power 0, then 10 to the power 1, then 10 to the power 2. So that is base 10. What might be the reason for it to be base 10? Because you have 10 fingers.
10 fingers.
Simple.
Yeah.
Now, certain other societies like Aztecs took it a bit further. They made it base 20.
Because you
because you have 10 more. Exactly. So they were like, what is the deal with just fingers? We have 10 toes as well. Let's make it 20.
What if you're wearing your Nike? What will you do?
So they made a system which was base 20, and Babylonians, they had a base 60.
60?
Yeah.
Did they count their, now, strands of hair or something? I don't know.
Now, these systems might sound a little absurd, but we are still using these systems in various aspects of our life. Can you imagine a system where base 60 is used? Time, clock.
Oh my God! So it came from the Babylonians.
Well, why do you divide your clock face into 60 parts?
Yeah.
And even if you look at how the degrees are calculated,
aren't they the ones who made a clock out of the sun rays and all that? They had that triangular that thing. I don't remember exactly.
Well, I don't know. We might have covered that in our clock episode.
Yeah, probably. I think we should do an episode on that Babylonian Empire.
Right.
Yeah, because they have done a lot of things, right?
I'm reading a book called The Richest Man in Babylon. It is mostly a financial advice kind of a book, but it's based on the philosophies that they used back then. I've just started probably, we'll talk about it later. But yeah, those systems are used. Even the way we measure degrees and stuff like that, it's 360 is not base 10. So the reason that this the base 12 and base 60 is important is because these, if you take 12 and 60 as numbers, right, they are very versatile. In fact, you can divide 60 by 1, 2, 3, 4, 5, right? Still they give whole
6.
numbers, right? 6 also. 7, no. So, but 10, then again 12, right?
Oh, wow.
So 15. So that is why, dividing the time and all those things become easier. So we wouldn't have realized, but we still use these kind of base 60 and all that kind of stuff.
Knowledge bombs.
Yeah. And then you have binary system, which is mostly used by everything that you see around these days. Electronics.
0, 1, 0.
Computers,
1,
electronics
0.
and everything. And now you would have heard of these natural numbers and stuff like that. Let's briefly touch upon that. Again, it's kind of a revision stuff. Now imagine, you remember the number line which we learnt in schools? It's like, imagine a straight line and you put numbers on the line like 1, 2, 3, 4, 5. Everything on the right of the number line, which is something that you see in the world, right? You see one mouse, you have 2 mics, we have 3 cameras. So these are natural numbers which occur naturally in the world. You don't see half a mic. I mean, you might see half a mic, but that's not useful, right? So stuff that is complete and natural in the world is called natural numbers.
And that comes on the right side.
That comes on the right, exactly, because it's like 1, 2, 3. So it keeps going till infinity, right? Now, let's say you take that mouse and put it in the other room. What happens?
It's not here.
It's not here. So how do you denote that?
I take it and throw it on the left side.
No, that's not what I meant. What I meant was when you add nothingness to natural numbers, means you add 0. 0 is right in the center of the number line, right? When you add 0 to natural numbers, it becomes a set of whole numbers. Why whole numbers? Because we need 0 to denote nothingness. So when you add 0 to natural numbers, it becomes whole numbers.
Whole numbers,
right?
okay.
Now it's not just 0. Suppose you borrowed money from me, right? Let's say you took 200 rupees out of from me. That means you owe me 200 rupees. Now, if you represent that in terms of numbers, it is negative. So that means your worth right now is minus 200, right?
Yeah.
How do you represent that? That goes on the left side of number line. And now you have this set where you have natural numbers, which is on the right side. Then you have 0 plus natural numbers, which is a whole set of whole numbers. Then you have these negative numbers coming in. Now that is again a set. That entire set is called an integer, set of integers. Right?
The negative ones.
Not just negative
I'm sorry,
ones.
the whole thing.
Negative plus 0 plus the positive is a set of integers. So integers can be negative, can be positive, it can be 0 as well. So yeah, natural numbers are denoted by the letter N. Whole numbers obviously denoted by the letter W. Integers are denoted not by I, it is denoted by the letter Z. Z because there is a term called Zahlen in German which means numbers,
I didn't know.
Which means numbers, and we just borrowed that word.
Germans come and contribute on at least something everywhere, right? Very good.
Yeah, my new headphones are also German. I like that.
You had to put that out. Well,
yes.
Anyway.
Now, let's say, consider this example. You have an apple. You cut it into half.
Oh, the fruit, okay.
Yeah, fruit. Not a MacBook or whatever. You have an apple fruit, you cut it into half, you give me half and you keep half. How do you represent that? That's not a whole number.
That's not, yeah.
So that becomes a ratio. It's like half of something, which is a fraction. So again, in between each integer, you have infinite number of fractions, right?
Yeah.
So that is also a part of this entire number system. Now, there are 2 kind of fractions, rational and irrational. Rational means it is evenly divisible. You divide 1 by 2, you get 0.5, you get 0.5. I get 0.5, you get 0.5. But if you divide 22 by 7,
3.14,
whatever, that keeps going and it doesn't repeat. So if the fractions that don't repeat and don't stop are called irrational numbers. So pi is a very good example for irrational number. And square root of stuff. What is a square? A square is like 2 into 2 becomes 4. A number multiplied by itself becomes another number. But what is the square root of 5? It is not.
It's rational.
Yeah, it's always approaching a number, but you can never reach that.
Yeah, you cannot definitely say that this is the value.
So irrational numbers mostly, if you look at trigonometry, right? Let's say you have a building with a window on the second floor, and you are standing like 5 meters away from the building. You can calculate the minimum length of ladder that you need to exactly reach that window.
Pythagoras.
Yeah, so their root comes into picture. So it is not entirely useless. It is a useful thing to understand irrational numbers as well. And as I said, there are terminating fractions and non-terminating. Terminating, for example, 0.5 and pi is an example of non-terminating. So these all play a part in our life, right? And all these collection. Now we have many collections, right? We had natural numbers, then we added 0, it became a whole number. Then we added negative numbers, it became a collection of integers. Then now we have fractional numbers. This entire collection together are called real numbers. Okay. Now you might ask, what is unreal number? There's no unreal number. There are imaginary numbers, which is, for example, square root of -2.
Yeah.
Like that is where this you remember that I thing which we studied in school? It was really pathetic. I hated that thing. I still don't understand
Plus or minus.
It's like imaginary number. How do you imagine an imaginary number? Right? So this is basically a small, understanding of what real numbers and whole number system is all about. I don't know if it is useful for someone, but I found it really fascinating to realize that this is what exactly it is. I had forgotten all these things, to be honest.
Same here. When we talk about, root plus or minus thing that comes into my mind is that, what is that? Root of b square minus.
Oh, by the way.
Something like
good,
that, right?
good that you brought that, because I'll tell you one thing. We spoke a little bit about Aryabhatta, right? Aryabhatta was not just popular for approximating pi. In fact, he is the person who found out a solution for summation of squares, like 1 square plus 2 square up to n square. That is
factorial.
Factorial is n into n plus.
Oh yeah. I got it.
This is 1 square plus 2 square plus 3 square plus up to n square. We have learned that in school. And this, it is equal to, let me find out, n into n plus 1 into 2n plus 1. That kind of stuff.
Yeah, I remember this? But I remember this
and
thing.
And similarly, he's found out something for 1 cube plus 2 cube plus 3 cube and all that. And this is back in 4th century AD.
That man was way ahead of its time. To be honest, he's not the man for 2000s too. Think about it. Yeah. Because we can't understand what he was talking about.
It's not just we. Most of us can't.
Most of us.
There's a small fraction of people who can really understand all these things.
The theory of relativity, when Edison came up with that, most of the people didn't know it back then. But now, I think a fair number of people who have studied it knows.
At least.
Yeah, you can understand. Yeah. But this thing, I think
I have immense respect for scientists and mathematicians, because I mostly don't understand most of the stuff, right? Even number systems and numerical analysis and all these integration, differentiation, let me not even go there, because I have still not really understood some of the concepts. But with the ease that they solve problems and all that, I have immense respect for mathematicians and maths teachers.
I think for them, it's like, they imagine all these numbers, it just pops up in their head.
I actually wanted to ask this, right? So when you hear a number, how do you imagine it to be? Let's say I give you a number 97, right? How are you imagining 97?
I've never thought about it, but now that you just asked me, what comes to my mind is just a blackboard with a 97 written with a chalk.
Do you know, for me, if it is a small number, in the sense, if it is somewhere near 100 and all that kind of stuff, I literally perceive a set of things or sticks or symbols like 1 to 10, then 10 to 20, and then I see them stacked up like 97. It's a black background and white color stuff.
I'm not crazy. Not crazy enough.
That's what happens. But when it comes to bigger numbers, when you say, let's say 2,000, 3,000 and all that, I see certain stacks of stuff. So that's how I relatively imagine things. Right.
For me, it's just the number just pops up.
But this number, these things are really interesting because they put things into perspective. If you look at human life, right? Let's say we live 60 years, average 60 years of proper life. 60 years is 60 into 52 is how much, right? Let's say 50 to make it very easy. It becomes 2,500. Yeah. 2,500 is the number of good weekends that we have in our life. If you represent 2,500 dots in a piece of paper, it's not that much.
Yeah.
Right?
Yeah.
So have that kind of things, put things into perspective. If you really want to really feel feel that existential crisis, go to Wait But Why. He has a post there where this exact thing is mentioned.
I have seen it, and I'm halfway through my life. If our life is,
if you want to feel a little more down, once we are done with this, go and listen to the song "Time" by Pink Floyd. The lyrics will really hit you hard.
And 2 of them are already dead, right?
That has nothing to do with this, but go and listen to that song. It was a song which Roger Waters wrote when he was 28, and he had this thing about
existential crisis.
You know what? Life is just passing by. What have I done in life, and all that kind of stuff. In spite of what he has already done by then.
What do we do then? We
are doing our Writer and Geek Show.
Oh yeah, 100th episode, the milestone.
Yeah, I would really like to take a moment. Anyway, we are done. So I would like to thank everybody who has supported us by listening, by being a part of this, and the fellow podcasters, our family members who have, tolerated us when we record and stuff.
And given us immense support.
Absolutely.
Yeah, let's just not put it that way.
And friends as well, who have always supported us, who have encouraged us, even if not, listening to all the episodes.
And friends who have, later on got into the bandwagon because,
And then also to the media who have, portrayed us in a very good light over the past 3 years.
Yeah.
And all our other podcast friends, whom we met when we after starting this journey. Thank you to everybody.
Let's not name any names.
Exactly. 100 episodes. Feels a little surreal because we never thought it's going to last 100 episodes.
Yeah, and what are the future plans, right? We are going to work on some series.
Yeah.
And
we'll keep you posted about it.
Yeah, we'll keep you posted about it. It's going to be really interesting. We have a few things in mind, hopefully. Yeah, it comes out good.
So thank you so much for all your support over past 3.5 years.
100. Peace out.